Hello, this is Lachelle Foley, and I want to introduce the new design in GEMS. It's very, very early times for this new design, and I expect that it will change a lot in the near future. We've recently hired a programmer, and I'm hoping the programmer will make a lot of the rough edges that you might see today be a lot less rough, maybe even kind of nice. So I'm talking about GEMS. GEMS is our Python interface to the C++ code in GMML. GMML does all the heavy lifting for us. GEMS is an interface. GEMS also serves as the interface between the computing machinery in the back end and Glycam Web, glycam.org. That's our website. So all the stuff that happens here, or pretty much all of it, goes through GEMS on its way to somewhere else. So GEMS talks to any external programs like Amber or whatever else has to be talked to. It also talks to GMML, which is our C++ code that I mentioned. This video is mostly going to introduce the directory structure and a little overview of why the new design exists. This is also a chance for me to test how good a job I did at making the design and at writing it. So this will be the first time that I have attempted to make a new service in GEMS using the new design. And I can't take time to edit video. Gosh, I hope that it's not too painful to watch. So anyway, this is sort of an overview of the architecture of GEMS. I have an incoming JSON API, and that is what the website or even users use. Like JSON API is what is used to communicate with GEMS. So if you're going to, on the command line, you're going to send input to GEMS, you're going to send a JSON object to GEMS generally, and you're going to get back a JSON object. So it's JSON API based even on the command line. But certainly also from the website. So that's on the website user end. On the other end, we have these completely arbitrary interfaces. So students in our lab who are graduate students, and they're doing some really fancy scientific work, and they need to write a program to do their work, and we would like to make their work available on our website. But it's really a lot to ask someone to get a PhD and to become an expert programmer in Python at the same time. Actually, it's kind of crazy and cruel, right? So the point of this design was to allow students and others to sort of be able to write whatever code they need to and have whatever interface is easy or natural for them, which, might be a command line with, 100, pieces of information in a predefined order after the name of the executable or whatever. I mean, it really doesn't matter. We're not trying to make the science students into, first-class programmers, but we want them to be able to just, get their scientific ideas into some sort of package, and then we want to be able to use that package and make it available to people on the internet. So we've got these arbitrary interfaces to student code or even to other code, like we need to interface Slurm and Amber, we need to interface, we do queries to Virtuoso database for the GlyFinder app. So lots of arbitrary interfaces. We also need GEMS. GEMS also has to interface to itself, right? So one GEMS entity might call another GEMS entity. For example, the MD as a service that I'm going to make right now or just start making, it will have to call Amber to make files, and it'll have to call batch compute to get, that will also call Slurm to create input files that are appropriate for Slurm, and then to submit submit the job to Slurm, right? So GEMS also has some internal stuff, and then of course Slurm itself is one of those arbitrary interfaces outside of GEMS that we have to deal with. So the design is all about this middle part. How do you get from a really user-friendly, very nice for anyone in the world interface down to whatever in the world you might have to deal with on the other end, and it really just truly could be anything, right? So the point of this design is this. It's a service-oriented architecture. It's not really microservices. We've tried to make the services be as, self-contained as possible, but the nature of our work doesn't make the typical approach to microservices really all that practical. When you have our jobs can take hours or weeks, and if you've got a queue with 1,500 things waiting in line, sure, those could all be services that are just up running and waiting for their chance somehow, but it's Slurm was designed to handle that, so we let Slurm do that. Anyway, I'm sorry, I'm babbling. Let's get down to trying to make some directories. Okay, so you're going to see there's the validation of the API that comes in. We need to translate that API into whatever GEMS needs inside. And then GEMS has got some logic it has to do. A lot of it you're going to see all this logic happening. And not in this video, but in some videos. Then you're going to translate into the service request needs and run the service. So this is the translation out of the user-friendly stuff into whatever GEMS needs to maintain its mostly accounting, a lot of accounting and other stuff. And then translation out to whatever this arbitrary interface needs in order to run, right? And then the arbitrary interface is going to give back heaven only knows what. And so we're going to have to receive those results from the arbitrary interface. So we have to translate those back into the GEMS internal logic, and then we translate them back into some API output that is presumably user-friendly. My first coding of this design is probably a little suboptimal, right? So, but it's the way it is, and I welcome programmer to try and simplify it a little bit. But what I want to look at right now is this is the delegator service. The delegator service is our main service. All of the APIs go through delegator. Delegator gets the API first and decides where it goes, and then sort of the receptionist in the lobby. Oh, you need to go to room 252B or whatever. So delegator says, okay, I've got this package coming in. Where does the package need to go? Sends it off to where it needs to go. But the delegator also performs a few services that you might expect. So what you see here is a list ls-r, so recursive list of the delegator, which is an entity. We call it an entity, and I've hidden all the PyCache directories because they'll just clutter things up. They don't really help us at the moment. So there's the delegator main directory, and then there's the delegator services directory. Delegator offers some services, offers known entities. What are the entities that it knows to other entities that it can hand off the API to? What are the services that delegator offers? It does have some other services that it offers, but those are common services, and they are in a different directory. So delegator inherits a lot of things from something called common, we'll show in a second. So there's a service directory, and inside of that directory, services directory, inside of that you have a directory for each of your services. You'll also have a settings directory that has settings that are applicable to the services. We'll talk about those in a minute. Delegator, so then for each of the services, you're going to see certain files. So so each service is going to most likely have something called an implied translator. So to make things easy for the user in the JSON interface, we have some sort of seemingly arbitrary statements in the interface, but they're there because it's what the user would think of to do. So we want it to be easy for the user to make this interface, but that's not necessarily the format we need things in. So we call those implied services. So I guess it's probably worth taking a look at some services. We'll get down there in just a second. When we get to the inputs, I'll show you some services, implied and explicit and implicit, using this little Easter egg called cake that comes to the Marco service, which I'll talk about in a minute. So anyway, there's an implied translator that translates from these implied services into actual services. there's a file you'll need to tell it for that service. How do you manage multiples? Like if someone has given you multiple requests for the same service, how do you handle that? Do you try to merge them together? Do you take the first one? Do you take the last one? Do you just issue an error, say I don't know what to do? Or you just run all the services? You know, different services will have different needs. And then you're going to have a server, and I haven't changed this file name to server yet, but you'll have a server.py, and that is the thing that actually handles the mechanics of, okay, I take in this information, I translate it, you know, into something else, and move along. Go to the thing, run the service, get back the response, etc. The server just does that last little bit of running the response and getting things back, and a little bit of translation. So let's see. The settings. So the modules for duplicates, so which we have some, instead of having a bunch of if-then statements, I tend to put modules into files, so duplicates modules, implied modules. The things higher up need to know if I have a certain service, where do I go to find the module? And instead of assuming beforehand a certain file name, we have the settings, and you know, that means that someone who's developing perhaps could, you know, temporarily set, instead of implied translator, you know, my new test implied translator or whatever, and they could run the code and just sort of plug that in and use a different module. I'm sure there are better ways to do that. I don't actually know Python. That's important to know right now. I don't actually know Python. Okay. Anyway, there's how to handle duplicates, the modules that handle implied services, what are known and available. So what are the known services? What are the available services? What are, you know, if someone asks, what can I do, or whatever, this is the file that has that sort of information. And then the modules to actually run for running a service. Delegator tasks. You have known entities. You have a services list. Tasks, sorry, I'm babbling. So in addition to services, you have tasks. So the services are things that we advertise to the public as services that we will perform on their behalf, right? So they can give us some sort of inputs, and we will, the input from the JSON API, and we'll turn that into something and give them back the JSON API, and it'll all be nice and neat and what have you. But those services are rarely just one thing. You know, they have to actually run something, and the something may be external, but something, or the some things may be internal. And when they're internal, that's what the tasks directory is for. So the let's just look at it. So get known entities, right? So in the known entities service for Delegator, there has to be some code that goes and figures out what the known entities are. That code lives down in tasks. It doesn't live in here because we want decoupling between them, right? We want decoupling, and we also want, you know, the get known entities. That could be useful for other parts of the Delegator code, not just for the service, the known entity service, or it may be useful for other parts of the code. I like to keep the decoupling. I don't really want too much of the other code using these services, but then they're there if it's just expedient to really just use them. Mostly they're there for Delegator. So Delegator, the get services list is especially useful. So a lot of the machinery will get the services list. It'll come here to this and get the list of services, and you know, for service in services, do all these other things, right? Get status app isn't really completely done, and that probably is not going to stay there. It's probably going to live in common. I'll show common in a second. The Delegator, there are some tests. We've started making tests, and not really going to go into tests too much, but I do want to show, I'll go into here and show you some of the JSON input at least, and maybe I could show some of the output, but I think the input right now is all we're going to really show today. So I'm going to cd into Delegator, and I'm gonna view cake explicit, So here's what I mean by cake explicit. Okay, so oh, let me don't do that. Let me do something else. Let's see. So let's talk about Marco first. Marco before cake. Okay. You probably know about ping, where you are looking for a remote server and you want to know if it's up, and you ping the server. You know, ping 8.8.8.8. Poor Google, they get pinged all the time for people who are testing their networks, or at least I do it. I'm sure I'm not the only one. So ping is sort of, I'm looking for a server. And we wanted something like ping, but we didn't want to call it ping because that's kind of got a specific meaning and gets used a lot. And we do a lot of stuff sort of in the cloud, and we also use gRPC in such a way that a service could just sort of call out into the void, hey, who's got, you know, who can give me something, right? It's more like an ARP request, I guess. No one but me knows what it is. I'm sorry. Okay, so you're sort of like, you know, calling out into this cloud, you know, who can respond to my request, right? And that kind of reminded me of Marco Polo. so our version of ping is Marco Polo. You yell Marco to our services, and if you get a response Polo, you know something's listening to the thing that you're calling out for, right? So this is the Marco request. It's the very basic thing. If you just want to test your connection, this is what you do. So here, this is what our JSON looks like. The entity is the only thing that's actually required in the JSON, and the entity type is the only thing inside of entity that's actually required. So if you send us nothing other than entity and type delegator, you will get back a response of Marco Polo, right? That's the default. You'll get the default service. The default service for delegator is Marco, the Marco service. So anyway, but if you're going to be explicit about it, so that would be implicit, right? If all of this is not there, the service is not there, and all you say is entity and type delegator, that's an implied request, right? You have implied that you want the default request, and you haven't explicitly said you want a service. If you explicitly say you want a service, then this is what we're talking about. In the services object inside of the entity, you have listed a service, and the services object is a dictionary. You give it your service a name, and the name is up to you. The name doesn't really matter. We'll use the name and echo it back to you. And you can, and then you have your services, and inside of the service there are certain, you know, what the Marco service needs is defined by the Marco service, right? Every service might need different sorts of inputs, but certain things are the same. Like they all need to know what is the type of service. So this is what you've named this service, but this is exactly the type of service. So for example, you might want to build, you know, different versions of a certain carbohydrate. We do carbohydrate chemistry. And, you know, so your service might be, you know, build structure number 1 and build structure number 2 and build structure number 3. But the types are always going to be build 3D structure, right? Because the type is the type of service, but then you can name them different things. Right now, in this simple request, those look redundant, and they kind of are, but we have to be able to handle more complexity. So this is an explicit service. So when I say explicit services, again, that's what I mean. So let's look at a default service. So I'm going to view the default service, and this is what I said before. This is what you get if all you do is give an entity and a type. You get the default service for that entity, and the default service is going to change from entity to entity. It's not always going to be the same thing. But for delegator, the default service is Marco Polo. And let's see, now let's talk about some implied services. So for this, I'm going to look at so there's an Easter egg, and I put the Easter egg in, it's the cake Easter egg. It was there specifically for design. It's there to give a little bit of complexity to the delegator so that we could design the services, and we're designing it with a service that doesn't really matter, right? So nobody is really going to get upset with us if the nature of the cake Easter egg changes one day, probably. So, it's just something that's kind of safe to mess with. So I'm going to look at view cake explicit. And this is important for understanding some of the stuff that we're going to see in a minute, the explicit, implicit, and such. And I'm probably not going to get too deep into directory structure before this video is done. I have to go to the grocery store. Okay, so anyway, let's see. So we have an explicit service, and I have named it Cake Marco. See, I can name it whatever. I could name it, Elizabeth if I wanted to, or something. Yeah, I named it Cake Marco. And in the Cake Marco service here, I have given it the type, which is required. The type of service is required. You got to tell it what kind. And I've also added these options: cake equals true and color equals pink. And the cake service does it will. So it's sort of a mashup of, I forget the video game. I don't play video games. I really don't play video games. But there are people who play video games. And in one of the video games, the cake is a lie. That's a thing, right? A thing. And then at the end, the cake appears and some woman sings opera to you. And it's really good, apparently. I don't know. I've just been told this. Okay. Anyway, so the cake, there's a cake. Is it a lie? Is it true? Is the cake true or false? So the first input is cake. Is my cake true or false? Is it a lie or is it the truth? And you have to have a color for the cake. And this comes from an Irish film called Cockamillish. And Cockamillish is... it says sweet cake in Irish, but it kind of just means cake. And what English speakers would mean cake. I have tried to ask what an unsweet cake would be in Irish, but I haven't gotten that far. Sorry. Okay. So anyway, so you can in the film, a pink cake is an important part of the film. Not going to spoil it for you, but there's a pink cake involved. And so you can give your cake a color, actually any description, but you can give it a color. So you can have a true or false cake, and the cake, in addition to being true or false, can also have a color, and you get back a response. All right, so that's the Easter egg. It allows me to do some things like, for example, handle implicit services. So let's look here at, I'm going to look at the implied cake. So, so an implied cake, here we don't have any services explicitly listed. We've said I've got, my entity is of type delegator, but I've just given some inputs. And my inputs are that the cake is true and the color is pink. So this is an implied service. I haven't said this is the service I want. I've just given some information in and expected Gems to figure out what is the most logical thing to do with that information. Or at least what is the predetermined thing to do with that information. Who knows what's going to actually happen, but Gems will decide something. So Gems, part of what Gems has to do, and this is part of that user-friendly bit, is it has to take some sort of inputs that are just easy for the user to use, easy for the user to add, then it has to translate those into actual services, because for computery decoupling reasons, you want the services to be able to run without having to go reading a bunch of inputs from JSON or something. You want part of what Gems does is it takes all these implied services and it translates them into explicit services internally. And in fact, the thing that you get back will have a list of all the explicit services that Gems created from your implicit and sometimes explicit services. So, for example, let's show an explicit and implicit version of cake. That works. Okay. So here we have the implied version of cake, but we also have an explicit version of cake. So this is for planning for, what happens when someone has asked for the cake Easter egg, but maybe they have done things that you don't expect. Like, for example, in the implied version, they want a pink cake that is true. but in the explicit version, they want a false cake that is purple. So what are we going to do? We're going to return an error. That's what we're going to do. We're going to say, I don't know what kind of cake you want. You got to be a little more, you got to make up your mind. All right. So, but still, we have to write into GEMS the capability for handling, what do you do when there are multiples? So, okay, let's go back to the directory structure. So in this directory structure, down in the services, so in delegator services, each entity has services, and inside of the services, what happens when I get multiples, or what are the rules that I use to translate implied information into actual physical, real services, right? So these are two of the parts of the entity services that you need to include when you're making a new service in this new GEMS model. Okay. Let's see now. Right, and then in the settings you have to say what the modules look like, and let's take a look at that because it's probably worth looking at. So. Okay, so here's how I handle which modules. Delegator actually offers a bunch of different different services. Sorry. So there's an error service for reasons of sometimes things just aren't right, and so there's an error service. I'm not done writing the error service, to be honest, but we will have one soon. There's a known entity service for delegator list services. What are the services that delegator offers? The Marco service that we just talked about, and the status service, what is my status? And for each of these services, there is, what do I actually run? What is the code that I actually run in order to perform this service? And the code has to have a very well-defined interface. It takes in this and it gives back that, right? So these modules are defined in very strict terms, so to speak, or at least in semi-strict terms, but depending on what they are. So this is a dictionary between a string and a callable. So this is a string, and this is a callable. And the callables are all defined up here. So here's the error. This is the translation for implicit services again. So this is the error implied translator, and that's, in this case, GEMS, the delegator is importing from common. So you can see common services. Common services are there for the services that all of the entities are going to need to offer. They're all going to have errors sometimes. They're all going to need to reply to Marco requests, and they're all going to want to say what their status is. They're probably also going to need to list their services, but since each one of them will have a different service list, they're not going to call the common service list necessarily. This could potentially change one day with someone who knows better Python than I do. I'm okay with that, but for now, each one will have its own implied list services translator. If it will have to have something. It might just say pass. It might not do anything. That does happen. And so anyway, so here's the module that's been imported, and you can see the module is echoed here. So this is one of the design things that I really like about Python, that I can just have a callable, and I can just say, here is the callable. And it also, like I said before, if you're trying to change the code, you could temporarily change this file so that it calls just some slightly different file here, right? And it could even still have, you can even keep this sort of name. But anyway, you can change what gets imported. But anyway, settings like this are, I like to keep in the settings, I like to keep all the sort of hard-coded stuff, the messy stuff, I keep it sort of in settings, or in really low-level files like the tasks. The tasks are for sort of the ugly code that might do whatever, and the services you know, some of the settings like how to manage multiples, that could be kind of messy looking code, and that's fine, right? So we're trying to keep the messy code sort of contained, but the basic code that controls flow is sort of well defined. And so this is the delegator entity, and I've mentioned common a few times. I'm going to, so I'm not going to, let's not look at the tests. Let's just look at, okay, so these are all the things that it takes to make delegator run. But that's not all the code that's required to do this, or at least not all the code that is written right now in my version in order to do this. So here's Jim's modules common. So this is the common entity, the common servicer. Will often call itself the common servicer if it's replying to you. If you get a response from the common servicer, something has gone horribly wrong. But the common servicer can respond to you if nothing else really can or knows how. Like if there's an error inside of Python, or Jim's, there's a bug, or Python vomits some exception or something, you're probably going to get a response from the common servicer, including information about that. Usually, not always. Anyhow, okay, so common has in its top level directory a lot of information. So there's lots of API information, the API information, main API. There's the main API that controls everything. I'm not going to try to talk about the API today, at least not in this video. This video is about directory structure and just what files are involved, right? So there's lots of files defining the API. These all define the JSON. The main API files define the JSON. Notice data, that's about, we have standard notices that might go back, you know, your sequence was bad, or we don't know what entity this is, you know, notices, certain sort of standard notices that you expect to have to respond often. That's the notice data, and notices are in the API for notices is defined here, and then notice data.py just is, there's a default factory in notices that uses notice data in order to create the list of notices, so that you can, in your code, you can say just return a 500 notice and give it this message, and it'll automatically build your notice for you and insert it. My computer likes to occasionally become very noisy. It's becoming noisy right now. Hopefully that is not bothering you too much, you poor listener. Probably telling me I should stop this video pretty soon, so I'll try to wrap it up before long. There's project manager, and this is not project management in the sense of you know, I'm managing a team of people. Project for us, project management is the project. Some services require a project, so they require a place to save data, to save state for later, you know, save data files for someone to download, right? So someone has built a certain carbohydrate structure or done a certain, you know, set of queries or whatever, and they want to save this information somewhere to retrieve later, and they want to do something with it. We call that a project. We put those into projects, and this is code for managing the projects. This code is not very well written quite yet. I'll probably have to flesh it out a little bit later, but it's going to be very minimal over the next couple of days. Receive and receiver. Receive is sort of the function that starts everything. You know, it receives the JSON API, but the receiver contains the class that sort of does the heavy lifting, the main work of the reception, right? Settings. I want to probably move settings around a little bit, but settings again is where some of the dirty stuff is. Transaction manager. So the API coming in is, we call it a transaction. So when you send us information, well, actually the transaction is kind of all of the information you give us in, all the information we give you back, and a little metadata around them usually, but mostly just all the information that comes in from you, from the user, and all the information that goes back to the user. And that's the transaction. And so there's code for managing the transaction. This is the main thing that manages everything that happens, because the transaction is what takes in all the information and returns all the information. So the transaction manager is sort of the superintendent, the site foreman. This is the one that says, okay, you do this and you do this and you do this, and then there are sub managers and such like. Inside of common services, there are the services that Common offers. So Common offers, or Common has template services. Common doesn't actually do anything. The only thing Common does is it responds to you when everything just goes horribly wrong. But Common also holds the templates for other services to do things. For example, error and list services and Marco, the templates for these, and status. The templates for these services live in Common because those are services that every entity is going to need to offer. In Common Services also, we've got lots of little pieces. For example, what is the default request? If all I've got is an entity and there are no services requested, what is the default? That gets defined. This is the template for defining that, and then you would define that again in your entity for your services. How do you handle duplicate requests? We'll worry about what an AAOP tree pair is later. How do you handle explicit requests? How do you handle implied requests? Orders and dependencies. So this is a template for specifying when you have multiple services and someone has requested multiple services, is there an order, as in this service needs to be run first and this service needs to be run after that? Or let's say someone has requested a service, and before you can do that service, you have to run some other services, and they didn't explicitly request those other services, but those services have to be run. Well, orders and dependencies is the thing that sort of holds that information. If I've got service C, I also need to run services A and B, or if someone has requested services C, D, and E, they should be run in that order, C, D, and then E, right? Let's see, data filler. This is, so in that cake explicit, so let's just go there. So here where there's an implicit request for a cake Marco, that has to get turned into an explicit request. And so the request data filler, part of its job is not just the implicit, getting that copied down into the service, but also anything else that the service needs. If the service needs to know where a file path is, if the service needs to know the identity of a remote server, if the service needs, whatever the service needs, the request data filler, that's going to fill into the service's body everything that the service needs in order to run, because we want a service request. It's actually a service request. The service request has to have all the information in that request. It shouldn't have to go looking anywhere else for information on how to run. So the data filler, its purpose is to make sure that each service request has all the information it needs in order to do its thing. And so then there's a request manager that's the request manager actually calls the data filler. So the data filler is a sub process sort of to the request manager. There's also a response manager. That's the manager that responds, that handles what happens when the service is run and what we've gotten back, whatever comes back from running the service. The response manager is what manages the transition between, what comes out of the service having run all the way back up to a proper API response to go back to the user. This is actually some utilities for lists of service packages. So, and we've got a list of services, service package. A service package is a service plus some other information. For the moment, just think of it as a service. I've got a list of services, and I want, okay, out of this list of services, give me all the services that are for type Marco. Okay, it's going to go into that list and just grab you all of the Marco services and give you a little sub list of that. It's just little utilities. That's what's in here. The servicer is the thing that actually runs services, that runs all the services, not a specific service. The servicer runs all of the services. So in the words that I chose here, these could change one day, but servicer is a thing that is a manager of multiple services, and the server is the thing that runs a specific service. That's the way I'm using it right now. No promises it'll have to always stay that way, but hey, whatever. Services and responses has to I can't remember what's in that file, to be honest. Let's see. Service tree manager, that's something else. Actually, service responses, I'm not really sure. That may be just an extra file that needs to go away. I'm not sure yet. We'll worry about that in another video. It may not be there later. Service tree manager, the service tree is a tree of services, and the service tree manager manages them. You may have services that the dependencies can be sort of complicated. So you could have, you know, A, B, and C need to be run, and then D is actually 5 different services, but those don't have to be run in any particular order. They just all have to be run, but they all 5 have to run before service E can run, that sort of thing. Service trees, that's a service tree, and the service tree manager handles all of that. And like I said, there were settings, and there's services. So in common services, each service, these are templates that are going to be useful to each service. So these are the abstract base classes that you're going to inherit from in each of the services. Just in an easy place, each service, that's where they are. So like you'll see an implied translator in each service and manage multiples in each service, but in the specific services, the error service or the list services or the Marco service, you'll see that those implied translator and manage multiples, those are there. You'll also see server, and yep, that should be server. Yeah, server is correct. Servicer probably needs to be deleted. Sometimes I've been working really hard for a couple weeks. I'm not completely done. Anyway, let's see. You'll also see an API. And all of these should have an API. They just don't all yet have an API. So the API defines sort of the low-level inputs and outputs that are needed for that particular service. So these are the inputs and outputs that are inside of the service, that are embedded into the API for the service. Those need to be defined at the service level. And let's see. Then, of course, there's, you know, the modules that need to be called for each of the services to run. That's the services. That's another service, the status service. And then, of course, here are the tasks, and there's the cake task that handles the cake. And let's see, some test input and some tests. All right. So if you're going to make a new new entity and a new service, then you're going to need to make essentially, you know, these directories. These are the things that you're really gonna need to do. You're going to need to have your entity, the name of your entity. That's going to be a directory. The entity is going to need to have a services subdirectory, and then inside of that service subdirectory, you're going to have each of the actual services itself will have its own subdirectory. There's also going to be a settings subdirectory that will contain information that is important about how to run your services. You're also going to have a tasks subdirectory, and the tasks subdirectory is mostly there to serve the services of the entity, but could also be used in other ways. If you have a task, by the way, that you find needs to be used by lots of other entities or lots of other places, there is a place for that, and I'll show that in a second. You're also going to have a test directory and some inputs and probably some correct outputs and such like. The tasks, it's just sort of, it's worth showing this in general. So the tasks, if you've got tasks that you think everybody's going to use, right, where do those go? So I'm in the, here, okay. So this is the gems modules plain directory, and most of this is actually useful. Okay, so the main gems modules directory has some entities. Mostly it's entities. A couple of things that aren't really entities. So the batch compute entity, common, we were just talking about. Delegator, we've talked about a lot. Deprecated, this is the old version of gems that we still have to use while we're transitioning to the new one, and we just put all of that down into a deprecated folder, so it's really, really easy to tell what's the new code versus the old code. We have some documentation. Actually, we always have git ignore me. Anything that has git ignore me in it is ignored by git, and it contains cruft and fluff and whatever you just don't want the rest of the world to see, right? We also have logging. I need to change the name of logging. It's not a really good name because it is used in other places, but there's where where the code for handling our logging lives. Molecular modeling service. Inside of that is going to be the new service MD as a service. That's what I'm going to add as an entity real soon, probably tonight. So here's the MM service directory. That's a meta entity, so if we list MM service, you'll see MD as a service, and that's the one that I have to add, and probably there's not a lot there, because I haven't done much. There's really not much in there. Yeah. So I'm starting from scratch. I'm probably not going to show the video of me making all the directories, but after I'm done with that, I'll make a video. Hopefully it won't take me very long to do it. That was the whole point of this, is to make it really easy to add new entities. Fingers crossed. Okay, but getting to the, and there's also the project entity and status. Okay, those are the entities. Common has lots of common stuff. Common has stuff that's common to all of the entities and the services that is really specific to GEMS itself, specific to an API or the provision of a service, something about that. And so if you've got something that a lot of different services are going to need, common is one place to consider putting that. But if it's something that's just a system operation, like I need to get the value of an environment variable, or I need to figure out the path, or I need to copy a file, or whatever. System operations, that's where you're going to have command line utilities, environment operations, file system operations. So things that are really going to be used by lots of different services and entities, they go in system operations. And then network connections is not really fleshed out yet, but the main network connection that we have to worry about is gRPC. We use gRPC to communicate often between different installations of GEMS. Like one installation of GEMS will use gRPC to call out and say, is there another GEMS that is on a server where it can do whatever? And, so anyway, the network connections, mostly right now that's gRPC, but other things could be added. So those are the places to store stuff that is in common. So common, like I said, if it's really specific to GEMS and what GEMS does, but we have other directories for things that are sort of more about the operating system or about the external environment, so network connections and system operations. Okay, let's see. Have I talked about everything I wanted to? I haven't looked at VS Code. Hey, I thought I might, but I'm not going to. So once again, this is GEMS, and this is the work that I'm doing right now is on the deprecate migrate branch. It will eventually be, I hope, merged into GEMS, and it will probably look a little different when that happens. But here is 106 commits ahead of actual, right? So I've been doing a lot of work here. Anyway, I hope this video was useful as an introduction to the new design in GEMS, and when that design updates, there will be other videos, certainly. And thanks so much for listening and watching.